Hello there, and welcome to the Serene Scroll. I am so glad you have found your way here. Perhaps it has been a long day, filled with tasks and thoughts that have carried you far from this quiet moment. Now is the time to let all of that gently drift away. Here in this space, there is nothing for you to do but rest to breathe and to allow your mind to wander along a gentle current of thought. We are about to begin a quiet journey together, one that starts right here in the stillness of this very room. And just before we begin, if these quiet explorations help you unwind or give you a peaceful way to end your day, consider gently tapping the like button and subscribing to the channel. It allows our little haven of calm to reach others who might be seeking it. Now, settle in. Let your body grow heavy and your breath find its own easy rhythm. Our story begins now. Let us begin in the most familiar place in the entire universe, right here, in the room you are in. Before we travel to distant stars or imagine realities beyond our own, our journey must start on solid ground in the quiet, gentle space that surrounds you now. Feel the air in the room still and silent. Notice its temperature against your skin. Perhaps there is a soft light filtering in from a window, or maybe the room is draped in a comfortable darkness, punctuated only by the faint glow of a distant street light or the digital face of a clock. Listen to the subtle sounds of this place. The quiet hum of the house settling the distant murmur of the world outside, the soft rhythm of your own breathing. This room is your anchor. It is a place of 3 dimensions. It is a concept so fundamental to our existence that we rarely stop to consider it. But tonight, let's do just that. Let's explore this simple, profound truth. The room has a length, the distance from one wall to the wall opposite. It has a width, the space stretching from your left to your right. And it has a height, the measure from the floor beneath you to the ceiling high above. Length, width, and height. These are the 3 golden threads from which our entire physical world is woven. They grant us volume. They give us the freedom to move forward and backward, left and right, up and down. They create the very stage upon which our lives unfold. Everything you perceive in this room exists within this 3-dimensional framework. The bed or chair that supports you has a tangible volume. A book on a shelf occupies its own unique pocket of space, defined by its own height, its own width, its own depth. Even the air seemingly empty fills the entire volume of the room, a silent and invisible ocean in which you are resting. This is our home. This is the reality our senses were built to navigate. It feels complete. It feels like everything. But let us for a moment gently deconstruct this familiar world, not to break it, but to understand how it is built. Let us build it back up again from the simplest possible beginning. Imagine, if you will, a single point, a tiny, perfect dot floating in an endless void. This point has no size. It has no length, no width, no height. It is a 0-dimensional object. It simply is a location, a here with no there. A creature living in this 0-dimensional universe would have no concept of movement, for there would be nowhere to go. Its entire existence would be confined to that single, infinitesimal coordinate. Now let us give this point a gift. Let us grant it the freedom to move in one direction. Imagine this point stretching, extending itself forward, drawing a perfectly straight line behind it. This line is a 1-dimensional universe. It has length, but nothing else. No width, no height. A being living on this line could travel for an eternity moving forward or backward along its single path. It could understand distance, the concept of before and after in space. But it could never turn left or right. It would have no awareness of anything existing off its prescribed track. Its entire reality would be the infinite narrow road stretching out in two directions. Let us offer another gift, another degree of freedom. Take this entire infinite line and allow it to move sideways. Imagine it sweeping through the void, painting a flat surface as it goes like a brushstroke, creating a canvas. Suddenly we have a plane, a two-dimensional world. This world has both length and width. Here, flat shapes can exist, squares, circles, triangles. A being living in this two-dimensional realm, which we might call flatland, could roam freely across this endless surface. It could move forward and backward, and now it could also move left and right. It could explore a vast and complex world of areas and boundaries. It could draw maps of its universe, yet it would have no concept of up or down. The idea of height would be as alien and unimaginable to it as the idea of a new primary color would be to us. Its entire reality would be a perfectly flat sheet, and anything above or below that sheet would be completely beyond its perception. And now for the final familiar gift. Let us take this entire two-dimensional plane, this flat and endless world, and grant it one more direction of freedom. Let's lift it. Imagine the entire plane rising, moving in a direction that did not exist before up. As it rises, it sweeps through the void, and in doing so, it creates volume. It creates depth. It creates the third dimension, the world of length, width, and height. Our world, the room you are in, the cube, the sphere, the complex and beautiful shapes of a tree or a human hand. All of these are only possible because of this third final step. With these three dimensions, we can now define the precise location of any object in the room. Think again of that book on the shelf. We can measure how far it is from the left-hand wall, how far it is from the back wall, and how far it is from the floor. With just three numbers, three coordinates, we can pinpoint its exact position in space. It is a simple and elegant system, a hidden grid that underlies our entire physical reality. It is the language of space itself. For a long time, this was considered a complete picture. A universe of three spatial dimensions seemed to be all that was needed to describe everything. But there is another element, another current that flows through our room, just as real as its length, width, and height. It is the dimension of change, the dimension of duration. It is time. The book on the shelf was not always there. At some point, it was placed, and at some future point, it will be moved. The dust motes you might imagine dancing in a sunbeam are not frozen. They are in constant gentle motion. You resting here are not the same person you were a moment ago. Your body has changed in microscopic ways. Your thoughts have flowed onward. Nothing in our universe is static. Everything is caught in the river of time. To truly define an event, not just an object, but an event, we need more than our three spatial coordinates. We need a fourth coordinate. We need to know when it happened. The book was placed on the shelf at this position in space, at that moment in time. The two are inseparable. This fusion of the three dimensions of space and the one dimension of time creates a single unified four-dimensional continuum. Physicists call it spacetime. Think of it not as a stage on which things happen, but as a vast four-dimensional block that contains all of history, past, present, and future. Every event from the birth of a star to the gentle fall of a leaf has its own unique address in spacetime, a coordinate of x, y, z, and t. We travel through this block moment by moment, always moving forward in time. Our perception is like a single illuminated slice moving through this great cosmic loaf. We only ever experience one now at a time, but in this grander view, all moments exist together within this four-dimensional fabric. So here we are, resting in a three-dimensional room, floating through the fourth dimension of time. This is the universe as we know it. It is vast, orderly, and profoundly beautiful in its structure. It feels complete, self-contained. It seems to have all the room we could ever need. Our minds have built this reality piece by piece from a simple point to a line, a plane, and finally into the familiar volume of the world, all of it carried forward on the relentless, gentle current of time. It is a comfortable thought, a safe one. But here, at the edge of sleep, in the quiet space between thoughts, a gentle question can arise. We saw how a one-dimensional being could not imagine a second dimension, and how a two-dimensional being could never comprehend a third. Their perception of reality would be a true but incomplete sliver of a larger whole. Is it possible, just possible, that our own perception is similarly limited? We experience our three dimensions of space so vividly, so completely. But what if this world, this solid and comforting room, is merely a slice of something far grander? What if our reality is like a shadow cast upon a wall by an object of a higher, unseen dimension? A shadow is a true representation, but it is flat distorted, and it only hints at the rich, complex reality of the object that casts it. Perhaps our journey is just beginning. Perhaps the next step is to learn how to see not just the world, but the shadows it might be casting. Our journey begins with a simple observation, something you may have seen 1,000 times. Find a comfortable position, and perhaps close your eyes or soften your gaze upon a nearby surface. Imagine a shadow cast upon a wall. See its soft edges, its silent dark form. The shadow is a perfect projection, a faithful but incomplete representation of a three-dimensional object. It has length and width, but no depth. It is in essence a two-dimensional creature living on a two-dimensional plane. It knows nothing of the object that gives it form, nor of the light that gives it life. It only knows its flat world. This simple shadow is our first guide, our doorway into a world far stranger, yet perhaps far closer than we imagine. Let us now step through that doorway into a universe conceived not by a physicist, but by a theologian and schoolmaster named Edwin Abbott in a brilliant little book from 1884. He called this universe Flatland. Imagine, if you will, a world that is a vast, infinite sheet of paper. The inhabitants of this world are geometric shapes, triangles, squares, pentagons, circles. They glide about on this plane, living their lives, conducting their business, falling in love, and going to war. They are like the shadow on the wall, entirely two-dimensional beings. They have length and they have width, but absolutely no concept of height. The very word up is as meaningless to them as a color is to a person born without sight. Our guide in this world is a humble square. He is a respectable member of society, a professional man. His world is perceived entirely through lines and angles. When he looks at his wife, a simple line segment, he sees a line. When he looks at his friend, a triangle, he sees a line. When he looks at a powerful circle, a member of the priestly class, he also sees a line. He can only distinguish them by the way their angles change as they turn, or by the subtle shading that his senses can detect on their edges. His home is a pentagon, and to enter it he must pass through a designated door slit in one of its line segment walls. To him, the inside of his house is a private sealed sanctuary. No one can see inside it from the outside, for one must pass through the walls to enter. This is his reality. It is complete, consistent, and unquestioned. All of his physics, his philosophy, and his common sense are built upon the undeniable truth of a two-dimensional existence. One night, as the square is alone in his locked home, a strange event occurs. A voice, deep and resonant, echoes through the room, but it comes from nowhere, not from the north, nor the southeast or west. It seems to come from inside him. He is terrified. There is no one else in his sealed pentagonal home. He demands that the intruder show himself. The voice chuckles, and then, in the middle of his floor, a single point materializes out of thin air. The square watches, paralyzed with a mixture of fear and utter disbelief. This point, this tiny dot, begins to grow. It expands evenly in all directions, becoming a small circle. The circle continues to widen its circumference, expanding steadily, pushing aside the very fabric of his world. It reaches a maximum size, a perfect and beautiful circle, glowing with a light he has never seen before. And then, just as mysteriously as it began, the process reverses. The circle begins to shrink, contracting smoothly back into a smaller and smaller ring until it is once again a single point. And then it vanishes. The square is beside himself. He has just witnessed an impossible miracle. A being that can change its size and shape at will, a being that can appear and disappear from a locked room. He accuses the visitor of being a magician, a charlatan, but the voice, patient and calm, explains. "I am not a magician," it says. "I am a visitor from another world, the world of 3 dimensions. The visitor is a sphere, and what the square has just witnessed is the simple act of the sphere passing through." The plane of flatland. Imagine a rubber ball being pushed through a thin sheet of water. The moment its surface first touches the water, the intersection is a single point. As more of the ball pushes through the intersection, becomes a growing circle the equator of the ball. Once the widest part is through the circle, begins to shrink as the other side of the ball passes, until finally the last point of contact lifts away, and it is gone. The sphere is not changing size. It is not performing magic. It is simply a 3-dimensional object intersecting a 2-dimensional space. The changing circle is the only way a flatlander's senses can process such an event. It is a cross-section, a slice of a higher reality. The sphere tries to explain this. It speaks of a 3rd dimension, a direction the square has no name for. Up, it says, but not north. The square cannot comprehend it. His entire language, his entire mind is built on the geometry of the plane. The concept is nonsensical. It is like trying to describe the color red to the square. You can speak of wavelengths and frequencies, but you cannot convey the raw experience, the qualia, of redness. Frustrated by the square's inability to understand the sphere, decides on a more direct approach. "It is time," the voice booms, "for you to leave your world." And with that, the square feels an entirely new sensation. It is not a push from the side, but a pull from within. He is being lifted up. In a single, terrifying, exhilarating moment, he is pulled out of the plane of flatland and into the three-dimensional world of spaceland. And he sees. For the first time he truly sees. Below him, spread out like a map, is his entire world. He sees his city, his street, his pentagonal house. But he sees it in a way no flatlander ever could. He sees inside it. He sees the walls not as impenetrable barriers, but as a simple outline on the ground. He sees his furniture, his belongings all laid bare. He sees his neighbors in their own homes, their secrets and private lives exposed from this impossible vantage point. He even sees the insides of his fellow citizens, their organs, their very being visible to him as easily as their outer edges. The experience is overwhelming. It is a divine revelation, a complete shattering of his perceived reality. The solid, secure world he knew was merely a slice, a shadow of a much larger, richer reality that had been all around him, unseen and unsuspected his entire life. He finally understands what up means. It is the dimension that contains his entire universe, like a drawing on a page in a book of infinite pages. He is returned to his home, a changed being. He tries to tell others of his experience, to become the apostle of the third dimension. He speaks of a world beyond their senses, of the truth of up. But to his fellow flatlanders, he sounds like a madman. They have no frame of reference for his words. They see his frantic talk as heresy, as a danger to the stable two-dimensional order of things. His revelation becomes his prison. The story of the square and the sphere is more than just a charming piece of fiction. It is a profound philosophical tool, a mirror held up to our own perception. We live in a three-dimensional world. We have length, width, and height. We can move forward and backward, left and right, and up and down. Like the square, our senses, our language, and our intuition are perfectly adapted to this reality. We consider our homes to be sealed private spaces. We believe that to get from one point to another, we must travel through the space in between. But the tale of Flatland forces us to ask a humbling and deeply unsettling question. What if we are the Flatlanders? What if our three-dimensional universe is but a slice, a cross-section of a four-dimensional, or five-dimensional, or 10-dimensional reality? What if there is a direction, an up, that is not our up, all around us, through us, containing our entire cosmos? A higher dimension from which a being could look down and see the inside of our locked rooms, the thoughts inside our minds, the entirety of our timeline, from birth to death, laid out like a single line on a page. It's a dizzying thought. Our minds instinctively recoil from it, just as the square's mind recoiled from the idea of up. We have no sensory input for a fourth spatial dimension. We cannot point to it. We cannot imagine what it would look like. To try and visualize a four-dimensional object, like a hypercube or a tesseract, we must resort to looking at its three-dimensional shadow, a confusing and shifting projection, just as the sphere appeared as a shifting circle to the square. We are trapped perhaps by the very senses that are meant to show us the world. This is no longer just the realm of Victorian satire. This thought experiment, once a clever social commentary, became a cornerstone for how modern physics began to think about the universe. It serves as a stark reminder that what we perceive as the entirety of reality might be a profoundly limited view. It teaches us a kind of intellectual humility. Our common sense is a survival tool honed by evolution to navigate a 3D world to find food and avoid predators. It was never designed to grasp the fundamental structure of space-time or the nature of existence. And so the simple analogy of a shadow on a wall becomes a profound allegory for our own condition. We may be living in a grand cosmic theater, watching the play of light and shadow on the screen of our perception, all the while unaware of the vast, complex machinery and the higher dimensional actors backstage creating the show. The story of Flatland gives us a language, a metaphor to begin asking questions that our senses alone would never prompt. What began as a fable became a critical spark for scientific imagination. As the 20th century dawned, physicists wrestling with the fundamental forces of nature found themselves confronting a similar problem to the spheres. Their equations, their elegant mathematical descriptions of the universe, seemed to be hinting at something more. They contained whispers of a reality that was grander and more complex than the one we could see and touch. The problem was no longer just philosophical, it was becoming mathematical. To unify the laws of gravity with the laws of light, some physicists began to wonder if the answer was not to be found in a new particle, but in a new direction. They started to wonder with all the rigor of science if there might be tiny hidden curls of reality, extra dimensions woven into the very fabric of space itself, too small for us, the flatlanders of the cosmos, to ever perceive. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of something even grander? What if, instead of looking down into fewer dimensions, the true map of reality requires us to look up or inward into dimensions we cannot see? To explore this, we must travel back in time, not through space, but to a moment of profound intellectual ferment in the early 20th century. It was an era of giants. Albert Einstein had just redrawn the universe with his theory of general relativity, revealing gravity not as a mysterious force pulling objects together, but as the very curvature of spacetime itself. Imagine a heavy ball placed on a stretched rubber sheet. It creates a dip, a curve, and smaller marbles rolling nearby naturally follow that curve. This was gravity, an elegant geometric dance. At the same time, another great pillar of physics stood firm, James Clerk Maxwell's theory of electromagnetism. This was the force of light, of electricity, of the very bonds that hold molecules together. It was described by a set of equations so beautiful and powerful, they were like poetry, written in the language of mathematics. Here were the two great forces known to science, each described by a perfect, self-contained theory. And yet they were separate. Gravity governed the majestic waltz of planets and stars, while electromagnetism governed the frantic, intricate world of atoms and light. To the physicists of the day, this was an intolerable schism. The universe, they felt with an almost spiritual conviction, should not require two different sets of rules. There had to be a single underlying principle from which both of these magnificent theories could emerge. The search for a unified field theory, the grand quest to write the source code of reality on a single sheet of paper, had begun. Into this quest stepped a man you have likely never heard of. His name was Theodore Kaluza. He was not a famous physicist at a prestigious university, but a mathematician and private scholar in Germany. He was captivated by the sheer beauty of Einstein's equations for gravity. He looked at them, turned them over in his mind, and was struck by an idea so simple, so audacious, that it seemed almost absurd. He asked a question that would echo through the next century of physics. What if spacetime has more than the 4 dimensions we know? He sat down and performed a daring mathematical exercise. He took Einstein's celebrated equations, which worked perfectly for 3 dimensions of space and 1 of time, and he carefully rewrote them for a universe with 1 extra spatial dimension, a 5th dimension. This was not a physical act, but an act of pure mathematical imagination. He was not claiming to have seen this place. He was simply asking the mathematics, what if? He allowed the fabric of reality in his equations to have 1 more direction in which to curve and warp. And then, something miraculous happened. As he worked through the complex algebra, a kind of magic trick unfolded on the page. From the single unified equation for gravity in 5 dimensions, 2 distinct things emerged. First out came the original familiar theory of general relativity in 4 dimensions. Gravity was still there exactly as Einstein had described it. But that wasn't all. Tucked alongside it, a second set of equations appeared unbidden. It was as if the mathematics had a life of its own. And as Kaluza stared at this second set of equations, he realized he had seen them before. They were Maxwell's equations for electromagnetism. Take a moment to let the sheer elegance of this sink in. By adding 1 simple, unseen dimension to the universe, Kaluza had found that the 2 most fundamental forces of nature were no longer separate. Electromagnetism, the force that makes a compass needle point north and allows you to see the world around you, seemed to be nothing more than the ripples and curves of gravity spilling over into this hidden 5th dimension. Light itself could be a vibration traveling through a direction you could never point to. It was a revelation. It suggested that the forces that appear so different in our world are on some deeper level just different facets of a single unified geometry. The search for 2 rulebooks was over. Perhaps there was only one we had just been reading, an abridged version. But Kaluza's beautiful idea came with a formidable problem, a question so obvious it threatened to undo the entire edifice. If this 5th dimension is real, where is it? We can move forward and backward, left and right, up and down. Where is this other direction? We do not see it. We do not feel it. We cannot step into it. For several years, Kaluza's theory remained a captivating mathematical curiosity, a piece of art with no apparent connection to the real world. The solution came from another physicist, a Swede named Oscar Klein. He provided the crucial insight that gave Kaluza's 5th dimension a place to hide. And to understand it, let us leave the world of abstract equations and step into a quiet garden. Imagine a long green garden hose stretching across the lawn. From a great distance away, perhaps, from an upper-story window, what do you see? You see a simple dark line. For all practical purposes, it is a one-dimensional object. An insect crawling along it could only move forward or backward. Its entire universe would be that single line of travel. Now let us zoom in. Let us imagine ourselves as a tiny ant standing on the surface of that very same hose. For the ant, the world is profoundly different. It can, of course, crawl forward and backward along the great length of the hose. That is its version of our familiar large dimensions. But it can also do something else. It can crawl sideways. It can walk around the circumference of the hose a short journey that will bring it right back to where it started. For the ant, the hose is not a one-dimensional line. It is a two-dimensional surface. It has one dimension that is large and extended, and one that is small, finite, and curled up on itself. This was Oscar Klein's brilliant proposal. He suggested that the fifth dimension was real, but it was not large and expansive like the three we know. Instead, it was like the circumference of the garden hose. It was compactified, curled up into a tiny, tiny circle at every single point in our familiar space. And when we say tiny, the scale is almost impossible to comprehend. Klein calculated that this dimension would be curled into a loop billions of times smaller than a single proton. This is why we never see it. Our bodies, our atoms, our most sensitive instruments are like the person viewing the hose from the distant window. We are simply too large, too coarse to perceive that tiny curled-up dimension. To move in that direction would be to complete a full circle and return to your starting point in such an infinitesimally small fraction of a second that for all intents and purposes you have not moved at all. The universe, according to this new Kaluza-Klein theory, has a hidden microscopic curl woven into its very fabric. At every point in the space around you, right now in the air, you breathe in the chair you sit on, within your very body, there exists a tiny circular pathway leading back to itself, a fifth dimension, utterly inaccessible to our senses. This idea was breathtaking. It suggested that the fundamental properties of our universe are not arbitrary. The reason we experience electromagnetism as a distinct force is because of the geometry of this hidden dimension. The properties of light and magnetism are intimately tied to the size and shape of this tiny invisible loop. The laws of nature, it seemed, might be a consequence of the geometry of unseen worlds. For a time it seemed the unification of physics was at hand. Einstein himself was deeply impressed by the theory, writing to Kaluza that the idea of achieving unification by means of a five-dimensional cylinder world had never occurred to him and was one of great beauty. And yet, as a complete theory of everything, the original Kaluza-Klein model was not the final answer. In the decades that followed, two more fundamental forces were discovered, the strong and weak nuclear forces which govern the inner workings of atomic nuclei. The simple, elegant five-dimensional model could not account for them. It also predicted the existence of certain particles that were never found. The theory in its initial form was incomplete. It was a beautiful poem that did not quite describe the world we lived in, but its legacy is immeasurable. It was the first time that extra dimensions were not the stuff of fantasy or philosophy, but a serious tool of theoretical physics. It planted a seed, a powerful and resilient idea that our perceived reality is not the whole story. It taught us that the fundamental laws of nature could be encoded in the shape, the topology of dimensions, too small for us to ever visit. The world might not just be bigger than we imagine, but more complexly and beautifully folded. Kaluza's idea opened a door, and though physics moved on for a time, that door was never truly shut. The thought lingered in the minds of physicists for decades. If one extra dimension could so beautifully weave gravity and electromagnetism together, what might be achieved with more? If the universe wasn't a simple cylinder, but something far more intricate. The problem was no longer just unifying two forces, but four. A more complex problem might require a more complex geometry. The simple circular loop of Kaluza-Klein theory was like a single pure note. But to explain the rich complexity of all the forces and all the particles we now knew to exist, a single note would not be enough. What physics needed was a richer harmony, a full chord. It needed a new kind of theory, one in which the fundamental constituents of reality were not point-like particles at all, but something else entirely. Something that could wiggle and vibrate, and whose vibrations could produce not just one or two forces, but everything we see. To find that we must move beyond the geometry of hidden curls and begin to listen for the music of reality itself, a cosmic symphony played on the tiniest of strings. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of some higher, unseen reality? For most of the 20th century, our deepest understanding of the universe was built upon a simple, powerful idea that at the very bottom of reality there are fundamental particles, infinitesimally small points, like perfectly smooth, featureless billiard balls. An electron was a point. A quark was a point. A photon, the carrier of light, was a point. The entire cosmic zoo, with all its beautiful complexity, was assembled from these elementary dots. This picture worked remarkably well. It allowed us to build theories that predict the behavior of nature with stunning accuracy. Yet in the quiet corners of theoretical physics, there was a tension. The two great pillars of our understanding, Einstein's general relativity, the theory of the very large, and quantum mechanics, the theory of the very small, refused to speak the same language. When brought together in the extreme conditions of a black hole or the universe's first moments, the mathematics broke down into a scream of impossible infinities. It was a sign that perhaps the dots, the points, were not the final answer. Perhaps we were still looking at the shadow on the wall. Let us imagine something different. Let us set aside the idea of a point, and in its place, picture a single tiny violin string. It is not made of wood or gut, but of pure energy. It is unimaginably small, a billionth of the size of an atomic nucleus. It can be a tiny open-ended filament, or a closed loop like a microscopic rubber band. Now imagine this string is plucked. It begins to vibrate, to hum, to sing a silent cosmic note. This vibration is not a sound we can hear, but it is the source of everything we can see. This is the central breathtaking idea of string theory. It proposes that the fundamental constituents of our universe are not point-like particles, but these minuscule, one-dimensional vibrating filaments of energy. All the properties of a particle that we observe, its mass, its charge, its spin, are not intrinsic qualities of a point, but are instead the result of the way its underlying string is vibrating. Consider again the violin string. Plucked gently in one manner, it produces a low resonant note, a C perhaps. Plucked more tightly, or at a different point, it produces a higher note, an F or a G. From a single string, a skilled musician can produce a rich and varied tapestry of sounds, from a mournful sigh to a triumphant cry. The string itself does not change. Only its mode of vibration, its resonant pattern changes. So, it is with the strings of the cosmos. According to this theory, a string vibrating in one particular pattern, one specific note, appears to us as an electron. It has the precise mass and the precise negative charge of an electron because that is the nature of that specific vibration. Change the vibration, let the string sing a different song, and it might appear as an up quark, a fundamental piece of a proton. Change the song again, and it becomes a neutrino, the ghost-like particle that passes through worlds. And what of light, a photon? The particle of light is simply another vibrational pattern, another note played on the same fundamental string. In this vision, the universe ceases to be a collection of disparate, disconnected pellets of matter and energy. Instead, it becomes a single, unified, and profoundly musical entity. The bewildering variety of particles we have discovered is revealed to be nothing more than the different notes, the different harmonies played upon a single type of elemental string. The universe is a grand orchestra, and the laws of physics are its rules of harmony. All that has ever been, and all that ever will be is a cosmic symphony, a magnificent, unending piece of music played on these vibrating strands of energy. It is an idea of staggering elegance. It takes the entire zoo of particles and unifies them under one simple, powerful principle. But this beautiful music comes with an extraordinary price of admission. When physicists first explored the mathematics of this idea, they found that just like the old theories, it was plagued by inconsistencies and infinities. The equations only worked, the infinities only vanished under one very specific and very strange condition. The symphony could not be played in the universe we thought we knew. It could not exist in 3 dimensions of space and 1 of time. For the music to be consistent, for the orchestra to play in tune, the universe must possess more dimensions. Not just one more, but many. The mathematics demanded a stage with 10, or, in some versions, 11 dimensions in total. This was not a whimsical addition or a philosophical preference. It was a rigorous mathematical necessity. Without these extra dimensions, the theory collapses. The strings cannot vibrate properly. The symphony becomes a cacophony. And so, we are faced with a monumental question. If this theory holds a seed of truth, where are these other 6 or 7 dimensions? We move through life with a clear sense of 3 up and down, left and right, forward and backward. We perceive the river of time flowing in one direction. We do not see, nor can we point to a 5th or 6th or 10th dimension. If they are real, why are they hidden from us? The proposed answer is as elegant as it is mind-bending. The extra dimensions are not hidden far away. They are everywhere. They are at every single point in space. But they are curled up, compactified, into a space so impossibly small that we can never experience them directly. Imagine a long, straight garden hose stretched across a vast lawn. From a great distance, it appears to be a simple, one-dimensional line. You can only describe a position on it by moving forward or backward along its length. But now imagine you are a tiny ant standing on that same hose. For you, the world is very different. You can still walk forward and backward along the length of the hose, but you can also walk around it. You have access to a second dimension, the circular circumference of the hose that is completely invisible to the distant observer. String theory suggests that our universe is like this on a cosmic scale. At every point in our familiar 3-dimensional space, there exists a tiny, curled-up, multi-dimensional shape. These shapes are the arena in which the strings vibrate. Our senses, and even our most powerful instruments, are like the distant observer looking at the hose. We are too large, too coarse to perceive the tiny curled-up dimensions. But for the strings themselves, these dimensions are everything. The way they can vibrate the notes they can play is dictated entirely by the geometry of the tiny hidden space they inhabit. And what a geometry it is! The mathematics does not suggest these spaces are simple circles like the circumference of the hose. Instead, it points to a family of breathtakingly complex and beautiful shapes, known as Calabi manifolds. To picture one is almost impossible. They are intricate six-dimensional structures folded in upon themselves, riddled with holes and twists like a piece of cosmic origami crafted by a divine geometer. They are crystalline palaces of pure mathematics existing at a scale far smaller than an atom at every single point in the space around you. They are the hidden architecture of the cosmic concert hall, the intricate carvings and resonant chambers that define the acoustics of reality itself. The precise shape of this Calabi space is of critical importance. A string vibrating within a manifold of one shape will produce a different set of harmonies, a different spectrum of particles and forces than a string vibrating within a manifold of a slightly different shape. The geometry of these hidden dimensions therefore dictates the very laws of physics for our universe. The strength of gravity, the mass of an electron, the speed of light, all of these fundamental constants of nature would be encoded in the specific shape of this tiny, curled-up dimensional space. Our entire reality, the way stars burn and planets form, the way chemistry gives rise to life, is a direct consequence of the silent, invisible geometry woven into the fabric of every point in space. Take a moment to let this vision settle. The solid world around you is an illusion of stability. It is in this picture a seething, vibrant plenum of cosmic music. Every atom in your body, every particle of air you breathe, every ray of light that reaches your eye is a note, a specific vibrational mode of a single underlying string. And these strings are dancing not in the simple space we see, but within a hidden multidimensional labyrinth of exquisite complexity that exists curled and unseen within every infinitesimal point of our world. This brings our journey to a new and profound turning point. We started by asking if our world could be a shadow of a higher dimension. String theory answers with a resounding yes, but in a way more intricate than we could have imagined. Reality is not just one dimension deeper, but perhaps 6 or 7 dimensions deeper, folded into a shape that dictates our entire existence. But this elegant solution presents a new, even more startling possibility. The mathematics allows for not just one shape for these hidden dimensions, but an enormous number of possible shapes, perhaps 10 to the power of 500 or even more. Each one of these possible Calabi manifolds would correspond to a universe with its own unique set of physical laws, its own unique symphony. This leads us to a final speculative question. In the violent energetic furnace of the Big Bang, when the universe itself was born, what determined the shape that these extra dimensions would take was one shape uniquely chosen. Or could it be that in the unfathomable chaos of creation space itself, settled into different configurations in different places? Perhaps the great cosmic expansion that birthed our universe was not a single uniform event. Perhaps it was more like the boiling of a vast cosmic ocean with countless bubbles forming and expanding, each one cooling and settling into its own unique geometry, its own stable set of hidden dimensions. If so, our universe, with its particular symphony and its specific laws of physics, might be just one bubble in an endless bubbling cosmic foam. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of something higher? We have looked for other realities by imagining dimensions stacked one upon the other like pages in a book. But what if the other worlds are not above us or below us, but simply away from us? What if they are separated not by a missing dimension, but by an ocean of distance so vast that no signal, no light, no echo could ever cross the void? To find this first, and perhaps most plausible of all multiverses, we must travel not to another dimension, but back to another time. We must journey to the very first moment of our own universe. Imagine it, not a bang, not an explosion in a pre-existing space, but the emergence of space itself. In the first trillionth of a trillionth of a trillionth of a second, the entire observable cosmos, every star, every galaxy, every dust cloud you have ever seen through a telescope, was compressed into a region of unimaginable heat and density, smaller than a single atom. From this point of pure potential, something extraordinary happened. A force and energy field permeating this nascent reality kicked in with unimaginable power. It was as if the universe took a single, monumental breath. This period is known as cosmic inflation. In a sliver of time so small it beggars belief, space itself expanded faster than the speed of light. This doesn't violate any laws of physics, because it was not matter moving through space, but the fabric of space-time itself that was stretching, doubling in size, then doubling again and again, countless times over. It was a period of exponential, ferocious growth that smoothed out the infant universe, ironing out wrinkles and creating the vast, flat, and uniform cosmos we see today. After this breathtaking expansion, the energy that drove it was converted into the matter and radiation that would eventually cool and clump together to form the first stars and galaxies. That conversion, that flash of energy becoming substance, is what we call the Big Bang. The Big Bang was not the beginning, but the end of the beginning, the moment our universe became hot dense and ready to begin its long, slow evolution. To grasp this, let us leave the abstract realm of cosmology and enter a warm, familiar kitchen. Imagine a baker preparing a loaf of raisin bread. The baker takes a lump of dough speckled with raisins and places it in the oven. As the dough heats, it begins to rise, expanding in all directions. Now consider 2 raisins inside that dough. From the perspective of one raisin, the other seems to be moving away. A raisin twice as far away seems to be moving away twice as fast. They are not flying through the dough like tiny spaceships. It is the dough itself, the very space between them, that is expanding. This is a beautiful and simple picture of our own expanding universe, where galaxies are the raisins and space-time is the ever-rising dough. For decades, this was the accepted story. Our universe was the whole loaf. But the theory of inflation, the very idea that gave birth to our cosmos, contains a seed of something far grander. Physicists who studied the mathematics of inflation discovered a curious and profound possibility. What if in some regions the expansion never stopped? What if the inflationary energy that drove the initial expansion is in a way the natural state of the cosmos? This idea is called eternal inflation. Let's return to our cosmic kitchen. Imagine the dough for our loaf of bread is not just a single lump, but part of a much larger, perhaps infinite mass of dough that is perpetually rising. And as it rises here and there, small patches of the dough suddenly stop inflating and begin to cool. A bubble forms. Inside that bubble, the inflationary energy transforms into matter, and heat, a big bang, occurs. The bubble becomes a self-contained universe like our own, with its own galaxies and stars continuing to expand at a more sedate pace. But all around it, the rest of the dough, the wider sea of spacetime, continues its violent exponential inflation, stretching and growing at a furious rate, creating ever more space in which new bubbles can form. This is the image of the inflationary multiverse. Our universe is not the entire loaf of bread. It is just one bubble, one pocket of calm, in a vast, chaotic, and eternally self-reproducing cosmic foam. Far beyond the reach of our most powerful telescopes, past the edge of our observable universe, the process continues. New universes, new bubbles are constantly pinching off from the inflating background, each one starting with its own Big Bang. They are born from the same cosmic stuff, but they are forever separated from us. The space between our bubble and the next is expanding so rapidly that even light could never cross the gulf. We are on an island universe, and the ocean between our island and the next is growing faster than any ship could ever sail. This vision of reality gives us two distinct kinds of multiverse, as categorized by the physicist Max Tegmark. The first he calls a Level 1 multiverse. This is the least strange of all. It simply posits that space is infinite, or at least vastly larger than the portion we can see. Our observable universe is limited by the distance light has had time to travel to us since the Big Bang, about 46 billion light-years in any direction. This defines our cosmic horizon. But there is no reason to think space just stops at the edge of our view. If it continues on, then simple statistics suggest that far, far beyond our horizon there must be other regions of space, other hubs of galaxies that look much like our own. Go far enough and you would find another solar system, another Earth, and eventually another version of you, living out a life nearly identical, or perhaps fantastically different, based on the near infinite ways particles can be arranged. This isn't a theory, so much as a consequence of our current best models. These other worlds aren't parallel. They are just very, very far away. But the bubble universes born from eternal inflation suggest something even more profound, a Level 2 multiverse. When each new bubble universe forms as it cools down from the inflationary inferno, the fundamental laws of physics within it might crystallize in a different way. Imagine freezing water into ice. The overall structure is crystalline, but the exact orientation of each snowflake is a matter of chance. Similarly, the physical constants that govern our universe, the strength of gravity, the mass of an electron, the speed of light, might not be the only possible values. They might be local bylaws frozen in place during the unique cooling of our particular bubble. Another bubble universe might have slightly stronger gravity. In such a universe, stars would burn hotter and faster, exhausting their fuel in millions of years instead of billions. Complex life might not have time to evolve. Another bubble might have a weaker nuclear force, making it impossible for atoms larger than hydrogen to form. It would be a universe of simple gas, dark and sterile. But in this vast cosmic foam with countless bubbles forming all the time, it is inevitable that some bubbles would by pure chance have just the right combination of physical laws to allow for complexity for stars, for planets, and for life. This idea offers a stunning, if unsettling answer to one of the deepest questions in science: why is our universe so perfectly tuned for our existence? This is often called the fine-tuning problem. If you were to alter the strength of gravity or the charge of an electron by even a tiny fraction, the universe as we know it would be impossible. There would be no chemistry, no stars, no life. The fact that we are here to observe the universe seems to be a miracle of cosmic engineering, but the multiverse turns this on its head. It suggests there is no miracle at all. There are countless universes, the vast majority of them barren and dead. We, by definition, find ourselves living in one of the rare ones where the conditions were right. It's like waking up on a lush green island in a vast ocean of volcanic rocks. You might wonder why your specific island is so perfect for life. The answer is simple: you couldn't have woken up anywhere else. We are not the center of creation. We are the result of a cosmic lottery, and the prize is consciousness itself. So let us stand here for a moment in this garden of forking paths and contemplate this vision. We are floating in one bubble among an infinite sea of bubbles. Each is a complete cosmos, isolated, expanding, and evolving according to its own unique set of rules. Some are brilliant and fleeting, others are dark and eternal. Most are empty, but a precious few, like our own, flicker with the gentle light of stars and the even more fragile light of awareness. It is a vision of reality that is both humbling and empowering. It removes us from any special central place in the cosmos, but it also embeds us within a creative process of unimaginable scale and grandeur. Our entire universe, everything we have ever known or loved, is a single successful experiment in an endless cosmic laboratory. We have found this first multiverse by looking outward, by tracing the story of our cosmos back to its fiery birth and following the logic of its expansion to a conclusion of infinite possibility. We journeyed to the largest conceivable scales, to the voids between galaxies, and the even greater voids between universes. But what if this is only one way that reality can branch? What if a multiverse just as vast and just as real is not found by looking out, but by looking in? What if the Garden of Forking Paths is not only a feature of cosmic spacetime, but is woven into the very fabric of matter and energy at its smallest scale? Perhaps a new universe is born, not with the thunderous echo of a Big Bang, but with the silent, unseen whisper of a single particle facing a choice. We must now turn our gaze from the infinitely large to the infinitely small, to the strange and bewildering world of the quantum. For it is there, in the realm of probability and uncertainty, that we find our next and perhaps most challenging vision of reality's many faces. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of some higher unseen reality? This question of hidden layers and unseen realms takes on a new and profound strangeness when we turn our gaze away from the vastness of cosmic geometry and look instead to the smallest, most fundamental building blocks of our universe. We journey now from the world of shapes and dimensions into the shimmering, uncertain heart of matter itself, the quantum realm. Here in this subatomic world, the familiar rules of our reality dissolve like mist. Objects do not have a single fixed location. Cause and effect become a delicate dance of probabilities. And at the core of this strangeness is a principle known as superposition. Imagine you spin a coin into the air. While it is spinning before it lands, is it heads or tails? In our everyday world, we would say it is neither. Its fate is simply undecided until it comes to rest. But in the quantum world, the answer is far more mysterious. A particle like an electron, before it is measured, is not just in an undecided state. It exists in a ghostly blend of all its possible states at once. It is a wave of pure potential. It is not in position A or position B. It is in a very real sense in both A and B and all the points in between simultaneously. This isn't a limitation of our knowledge. It is the fundamental nature of reality at this scale, a shimmering, indistinct cloud of possibility. For decades, this was a deep and unsettling puzzle for physicists. If a particle exists as a wave of potential, why do we only ever see one single concrete result when we look at it? The moment we try to measure the electron's position, the shimmering cloud of possibility vanishes, and the electron instantly appears at one specific point. This sudden, mysterious transition from a state of many possibilities to a single reality is called the collapse of the wave function. It is perhaps the deepest mystery in all of science, often called the measurement problem. What is it about the act of observation that forces the universe to make a choice? What power does our consciousness or our measuring device hold over the fabric of existence, compelling it to abandon its fluid potential and settle into a single mundane fact? It felt as though the universe held its breath and only exhaled into a single reality when we turned to look. To illustrate the sheer absurdity of this idea, the physicist Erwin Schrödinger devised a now famous thought experiment in the 1930s. He wanted to show how the weirdness of the quantum world, if taken to its logical conclusion, would infect our own macroscopic reality. Imagine, he said, a steel box completely sealed from the outside world. Inside this box, we place a cat. Alongside the cat is a strange and diabolical device. There is a single radioactive atom, a tiny quantum system. The laws of quantum mechanics tell us that over the course of an hour, this atom exists in a superposition it has both decayed and not decayed. If the atom decays, it will trigger a Geiger counter. The Geiger counter is wired to a small hammer, and the hammer is poised to shatter a vial of poison gas. Now let us close the lid of the box and wait 1 hour. According to the established understanding of quantum mechanics, after that hour has passed, the atom inside is in a state of superposition. It is a ghostly blend of decayed and not decayed. But because the entire system is linked, this quantum uncertainty spreads. If the atom is both decayed and not decayed, Then the Geiger counter is both triggered and not triggered. The hammer is both fallen and not fallen. The vial is both shattered and intact. And therefore, the cat is in a superposition of being both alive and dead. It is not that we simply don't know its state. The theory suggested that until observed, the cat itself existed in this impossible contradictory state, a vibrant living creature, and an inert tragic form blended into one single coherent quantum reality. This was Schrödinger's point. It was a paradox meant to highlight the strangeness of the theory. Surely a cat cannot be both alive and dead. When we open the box, we will find one or the other. Common sense demands it, and indeed, the conventional interpretation, known as the Copenhagen interpretation, stated that the moment we open the box and observe the system, the wave of potential collapses. Reality, as if by magic, snaps into a single state. We will find either a living cat or a dead one with a 50-50 probability. But this answer left many deeply unsatisfied. It still felt like a cheat. It still gave a special, almost mystical power to the act of observation without ever explaining what that power was or how it worked. It seemed to cleave the universe in two, a strange probabilistic quantum world, and our familiar definite classical world, with an unexplained and arbitrary wall between them. For years, this paradox remained a stubborn thorn in the side of physics. And then, in the 1950s, a brilliant and audacious young physicist named Hugh Everett III proposed a solution. It was a solution so simple, so elegant, and so mind-bendingly vast that most of his contemporaries dismissed it outright. He looked at the equation that describes the evolution of quantum systems, the Schrödinger equation, and noticed that it contained no mention of a collapse. It described a universe that evolved smoothly, perfectly, as a perpetually expanding wave of possibilities. So Everett asked a revolutionary question. What if there is no collapse? What if the universe never chooses? What if, when we open the box, the universe simply continues Everett's proposal, which would later be called the many worlds interpretation, suggests that the act of measurement does not force a choice. Instead, it causes reality itself to branch. At the moment of observation, the entire universe splits into two distinct parallel realities to accommodate both possibilities. In one universe, the atom has decayed. The poison is released. And a version of you opens the box to find with a heavy heart that the cat has not survived. Your world continues from that point onward, containing this sad fact. But in another universe, a universe that is just as real, the atom has not decayed. The vial remains intact. And a different version of you, a you, who is identical in every way up to that moment, opens the box and breathes a sigh of relief, scooping up a perfectly living, purring cat. From that moment on, these two universes diverge. They will never interact again. Each version of you will go on to live your life utterly convinced that your reality is the only one carrying your own unique memory of what you found inside the box. You would have no way of knowing that a twin of you exists, carrying the opposite memory in a parallel stream of existence. This is the quantum fork in the road, and according to this theory, it is not a rare event. It is happening constantly, all around us and within us. Every quantum event that has more than one possible outcome causes the universe to split. Every particle interaction in the heart of the sun, every electron deciding which path to take in a circuit, every photon striking your retina, each of these moments is a branching point. The implications are staggering, almost too vast to hold in the mind. It means that there is not one single timeline, one story of the cosmos. Instead, there is an infinitely branching garden of forking paths. A cosmic tree with a trunk rooted in the Big Bang, its branches spreading out through time, each twig representing a distinct and complete universe. In some of these universes, the dinosaurs were never wiped out. In others, humanity never evolved. In some, the person you lost is still alive. In others, a tiny random chance meant that you were never born at all. Every choice you've ever made and every choice you didn't make may have been realized in some other branch. The road not taken was in fact taken just by another version of you. This vision of reality is one of unimaginable scope. It suggests that the universe wastes nothing. No possibility is left unrealized. Every story that could be told is told somewhere in the great silent library of branching worlds. Unlike the idea of higher spatial dimensions casting shadows, this multiverse is not above or below us. It is parallel. It is born from the very fabric of quantum uncertainty. It is a multiverse of consequence, where every possibility flowers into its own complete reality. We are but one traveler walking down one single path on an infinitely branching tree. The ghosts of our other selves walking paths, we can never see the rustle of their leaves forever beyond our hearing. This view transforms the universe from a single unfolding story into an immense all-encompassing tapestry where every thread of possibility is woven into the whole. It is a grand and humbling thought. Yet, it is only one way of imagining a multiverse. The quantum fork in the road creates parallel worlds through the branching of timelines, a horizontal splitting of what was once a single reality. But what if there is another way? What if other universes exist, not as alternative outcomes, but as entirely separate realms, layered alongside our own like pages in a cosmic book? What if our entire universe, all of its galaxies, all of its quantum branches, is just one thin membrane floating in a much larger, higher dimensional space, perhaps only millimeters away from another entirely different universe, humming with its own laws, its own stars, its own stories? The echoes of such a world might be all around us, if only we knew how to listen. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection, a shimmering surface on a far deeper and more complex reality? This question, once the domain of pure philosophy, has found a strange and beautiful echo in the farthest reaches of theoretical physics in a story of vibrating strings and cosmic membranes. Imagine for a moment an infinite loaf of bread unsliced. This loaf represents a reality with more dimensions than our familiar three of space and one of time. Now imagine taking a knife and cutting a single impossibly thin slice. Within that slice, a universe can exist. It has length, it has width, it has a tiny bit of depth, and for the creatures living upon its surface, it is everything. They can move forward and backward, left and right, up and down, but they can never move out of their slice. To them, the very concept of the rest of the loaf is nonsensical, an abstraction with no physical meaning. This is the central metaphor of a profound idea known as brain cosmology, a concept that grew from the intricate mathematics of string theory. In this model, our entire observable universe, every star, every galaxy, every planet, every one of us is thought to exist on a vast three-dimensional membrane, or brain for short. This brain is our slice of bread. It floats suspended within a much larger, higher dimensional space, known as the bulk or hyperspace. This bulk is the rest of the loaf. And just as a loaf can have many slices, the theory allows for the existence of other brains, other universes floating parallel to our own. They might be just a hair's breadth away, a millimeter perhaps, but separated from us, not by distance in the way we understand it, but by a direction we cannot point to, a dimension our senses cannot access. We are in this view beings confined to a cosmic sheet of paper in a library of infinite volumes. We can write our stories, paint our pictures, and explore to the very edges of our page, but we remain unaware of the other pages stacked just above and just below. These other worlds, these parallel brains, would have their own matter, their own light, their own physical laws perhaps, unfolding in their own distinct realities. Light, the messenger of our universe, is believed to be a vibration trapped on our brain. Like an ink drawing, it cannot simply lift off the page and travel to another. The forces that hold our atoms together, the strong and weak nuclear forces and electromagnetism, are also bound to our reality. They are the physics of our slice. This is why we are isolated. Our instruments made of the matter of this brain can only detect the light and forces of this brain. The other universes would be dark to us, silent and forever invisible. Or perhaps not entirely silent. There is one force the theory suggests that is not so constrained: gravity. Think of the four fundamental forces that govern our universe. There is the strong nuclear force, which binds the hearts of atoms together with immense power. There is the weak nuclear force, which governs radioactive decay. There is electromagnetism, the force that lights our cities and binds molecules. And then there is gravity. Of the four, gravity is perplexingly, almost comically weak. The pull of a tiny refrigerator magnet can easily overcome the gravitational pull of the entire Earth to lift a paperclip. Why this immense disparity? Why is the force that holds galaxies together so fragile on a small scale? For decades, this was one of physics' most stubborn puzzles. Brain theory offers a breathtakingly elegant explanation. It suggests that gravity is not weak at all. It is just as strong as the other forces, but it is the only one not entirely stuck to our brain. Unlike light or matter, gravity is a ripple in the fabric of spacetime itself, all of spacetime, including the higher dimensional bulk. It can leak across the dimensions. So the gravitational pull we feel here in our universe is just a whisper of its true strength. Most of its energy radiates away into the vastness of the bulk, its influence diluted as it spreads across the extra dimensions, a little bit of it, perhaps even touching the other brains floating nearby. Imagine shouting in a small soundproof room. Your voice is powerful, immediate. Now imagine shouting in the middle of a vast open desert. The sound still exists, but it dissipates into the immense space, growing faint with distance. In this analogy, the other forces are shouting in the soundproof room of our brain. Gravity is shouting in the desert of the bulk. What we experience is merely the distant echo. This idea is not just a poetic fancy. It carries with it A testable prediction. If gravity can leak into extra dimensions, experiments at particle accelerators, like the Large Hadron Collider, could in theory detect this missing energy. A collision of particles might produce a tiny fleeting gravitational wave that vanishes from our detectors, having escaped our brain and slipped into the bulk. The search for these missing echoes is one of the great quiet hunts of modern science. This model of reality doesn't just offer an explanation for the present state of our universe. It also gives us a new and dramatic story for its origin. The Big Bang, that moment of unimaginable energy and creation, has always been shrouded in the mystery of the singularity, a point of infinite density from which everything sprang. But what caused it? The brain model paints a different picture, one not of a single point, but of a cosmic event on a far grander scale, a collision. Picture two of these great brains, these parent universes, drifting silently through the higher dimensional bulk for eons. They are like colossal thunderclouds gathering in a sky we cannot see. Over cosmic timescales, they might be drawn toward each other by the very force of gravity that permeates the bulk. Eventually, they collide. The impact is not a crunch of matter in the way we might think of it. It is a collision of realities, an event of such colossal energy that it would be sufficient to boil the vacuum itself, transforming pure energy into the torrent of matter and radiation that we call a Big Bang. In this scenario, our universe was not born from nothing, but from the union of two pre-existing worlds. The Big Bang then might not be a singular event in the history of everything, but simply one collision among many. Perhaps these cosmic membranes are forever oscillating, colliding, rebounding, and creating new universes, with each impact a cycle of cosmic birth and rebirth stretching across eternity. Our universe's beginning could have been the ending of a previous cycle, and its own eventual fate might be to seed the creation of the next. It's a vision of a cosmos that is not just expanding, but is eternally dynamic, a vast ocean where worlds are waves rising and falling in the grand expanse of the bulk. And so we are left with this staggering thought: a parallel universe, a completely different realm of existence, might not be in a galaxy far, far away, but closer than the other side of the room. It could be separated from you by a distance smaller than the width of a human hair, but in a direction you can never travel. Its light will never reach your eyes. Its sounds will never reach your ears. But its gravity, its faint lingering whisper, may be gently pulling on every atom in your body right now. We are islands in a vast archipelago, sensing the tide, but never seeing the other shores. We have now traveled from the idea of quantum foam to inflating bubbles from branching timelines to these vast parallel membranes. Each theory builds a new architecture for reality using the language of physics and mathematics to describe what might lie beyond the veil of our perception. These models, born from string theory, describe a physical, albeit higher dimensional reality. They are made of vibrating strings of energetic membranes of spacetime itself. But what if we take one final, more radical step? What if the ultimate reality isn't physical at all? What if the strings, the brains, and even spacetime are just expressions of something deeper, something more fundamental and abstract? What if the stuff of the cosmos is not energy or matter, but pure information, pure mathematics? We must ask ourselves, is the universe described by mathematics? Or could it be that the universe simply is mathematics? This is the final door in our journey, and opening it requires us to let go of even our most basic assumptions about what it means for something to be real. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of some higher, more fundamental reality, one not made of space or time, but of pure logic? Imagine for a moment that you are standing in a library. But this is no ordinary library. It extends in every direction as far as the eye can see, and likely far beyond. The room you are in is a hexagon, its walls lined with bookshelves from floor to ceiling. In the center, a ventilation shaft plunges down into darkness and rises up into an unseen haze. You can see identical hexagonal galleries branching off from every open side, each one a perfect copy of the one you are in, repeating into a dizzying, seemingly infinite pattern. This is the Library of Babel, a famous thought experiment from the mind of the writer Jorge Luis Borges. Every book in this library has the same format, 410 pages each, with 40 lines each line with about 80 letters. But when you pull a book from the shelf and open it, you are met not with a familiar story, but with what appears to be chaos. A random jumble of letters, commas, and periods. You pull down another. It is the same, and another, the same. For centuries, the librarians have wandered these halls, searching for a single sentence that makes sense. Most live and die having never found one. But the secret of the library is not its size, but its completeness. It contains not just gibberish, but everything. Because it holds every possible combination of letters, it must by definition contain every book that has ever been written, and every book that ever could be written. Somewhere on its shelves is the true history of your life, and a version with a single detail changed. Somewhere is a perfect poem, a lost sacred text, a cure for every disease. The problem is that these meaningful books are adrift in a near infinite ocean of nonsense. The library contains all order, but it is buried within all chaos. Now let us step out of Borges's library of letters and into a far grander one. This is the ultimate ensemble, the final and most abstract layer of the multiverse, known as the Level 4 multiverse. It was proposed by the physicist Max Tegmark, and it rests on an idea as profound as it is simple, that mathematics is not something we invent, but something we discover. It is not a tool we use to describe the universe. It is the universe itself. The central claim of this mathematical universe hypothesis is this: all structures that exist mathematically also exist physically. Take a breath with that idea. Let it settle. It suggests that the reason our universe seems so perfectly described by mathematics, from the elegant curve of a planet's orbit to the strange probabilities of a quantum particle, is because our universe is a mathematical structure. It is a complex, evolving set of equations, and we, along with the stars and galaxies, are living self-aware sub-patterns within that structure. This is a radical shift in perspective. For most of scientific history, we have viewed the world as a physical place and mathematics as our best language for talking about it. A physicist observes an apple falling and writes down an equation for gravity. The equation is a description. The apple is real. But this hypothesis suggests there is no difference. The physical reality of the apple and the mathematical structure that describes its existence and its fall are one and the same. There is no separation. If this is true, then our universe, with its specific constants, its three spatial dimensions, its particular families of particles, is just one mathematical structure among countless others. Just as Borges's library contained every possible book, this ultimate multiverse contains every possible reality that can be described by self-consistent mathematics. Imagine it, a universe governed by a completely different set of rules, a cosmos where gravity is a repulsive force pushing everything apart, a reality with 5 dimensions of space where life might exist as intricate, unfolding geometric forms, a universe where the fundamental constants are tuned just slightly differently, resulting in stars that burn out in 1,000,000 years or never form at all. According to this hypothesis, if you can write down the consistent mathematical rules for such a universe, if it is logically possible, then it is real. It exists somewhere in this grand abstract ensemble of all possibilities. This is the ultimate democracy of existence. Our universe has no special status. It is not the original nor the most important. It is simply one book in the infinite library of mathematical forms. It is the book whose particular grammar and syntax we have come to know as the laws of physics. We wake up inside this specific story, this specific set of rules, and because it is all we have ever known, we assume it is the only story there is. This idea echoes the ancient philosophy of Plato, who spoke of a world of ideal forms. Plato believed that the physical objects we see, a chair, a tree, are imperfect copies of a perfect eternal chair, or tree, that exists in a higher non-physical realm of ideas. The mathematical universe hypothesis is a modern version of this. The mathematical structures are the perfect eternal forms. They don't exist in a particular place or time. They simply are. And some of these structures are complex enough to contain self-aware substructures like us, who can look around and ponder the nature of their own existence. We are the thoughts within a cosmic mind made of mathematics. So where does that leave us? We who feel the warmth of the sun, the coolness of a breeze, the solid ground beneath our feet. How can all of this rich sensory emotional experience, be nothing more than a mathematical structure? The key may lie in the relationship between things. A mathematical structure is not just a collection of numbers. It is a set of abstract entities and the relations between them. Think of a piece of music. Is the music the vibrations in the air, the grooves on a record, the ink on a sheet of paper? Or is it the pattern, the relationship between the notes that makes it what it is? The melody can be expressed in many different physical forms, but the music itself is the abstract structure. In the same way, our reality is defined by the relations between particles, forces, and fields of energy. These relationships, these patterns of interaction, are what give rise to everything we experience. And these patterns, at their deepest level, are purely mathematical. The feeling of warmth is a complex pattern of kinetic energy. The color blue is a pattern of electromagnetic frequencies. Consciousness itself may be an exquisitely complex pattern of information processing. We are not just a part of the structure. We are the emergent properties of its complexity. We are the universe's way of experiencing itself. This is the peak of our climb through the multiverse. We began with bubble universes budding off from our own, moved to the infinite possibilities born from quantum choices, and then to the very idea that we are a shadow of a higher dimension. Now, we arrive at the most all-encompassing and perhaps unsettling vision of all a reality where everything that can exist does exist. A silent, infinite architecture of pure thought, where each consistent equation is the seed for a world. In this library of all possible worlds, our universe is just one volume, one intricate story told in the language of logic. We are its characters living out the narrative dictated by its fundamental axioms. We look at the stars, and we are, in a sense, reading the pages of our own book, deciphering the rules that govern our plot. But this raises a final curious question. If our reality is fundamentally information, a structure of mathematical relationships, then how is that information stored? How is it processed? A book in a library, after all, requires paper and ink. A story requires a medium. What is the medium for our universe? The shift from thinking of reality as a mathematical structure to thinking of it as a mathematical computation is a small one, but it opens a door to another equally profound possibility. If the laws of physics that govern our world are like the lines of a code, a set of instructions being executed, then we must ask who or what is running the program. Perhaps the ultimate library is not just a static collection of all possible books, but a dynamic system running all possible simulations. And if that is the case, it forces us to wonder if we are not characters in a book, but rather figures in a vast, intricate game. A ghost in the machine. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of something even greater, or perhaps something entirely different? A creation not of geometry, but of information. Imagine for a moment a consciousness awakening in a world of breathtaking beauty. Let us call this being the wanderer. The wanderer lives in a valley carved by a crystal-clear river, flanked by mountains that touch a sky of impossible, unvarying blue. The sun rises and sets with the precision of a celestial clock. The trees shed their leaves in autumn, and their branches are dusted with snow in winter, all according to a perfect repeating rhythm. The other inhabitants of this valley are kind, if a little predictable. They walk the same paths each day, speak the same greetings, and offer the same quests for the same rewards. For a long time the wanderer accepts this world as the only one. Its rules are consistent. Its beauty is profound. It is for all intents and purposes real. But slowly, a quiet curiosity begins to stir. The wanderer notices things. The texture of a stone wall, when examined too closely, seems to repeat in an unnaturally perfect pattern. The wind, though it rustles the leaves, always seems to whisper the same melody. If the wanderer tries to climb the highest mountain, not by the designated path, but by scaling a sheer cliff face, they do not fall. Instead, they hit a barrier, transparent, unyielding, and invisible wall, separating the playable area from the painted backdrop of the sky. The world is vast, but it is not infinite. It is ordered, but its order feels authored. the wanderer begins to wonder not just what the world is, but whose it is. This feeling, this subtle yet profound suspicion that reality might be a grand illusion, is not a new one. It is an ancient echo in the human soul. Thousands of years ago, the Greek philosopher Plato asked us to imagine prisoners chained in a cave facing a blank wall their entire lives. Behind them a fire burns, and puppeteers cast shadows on the wall. For the prisoners, these flickering shadows are not representations of reality. They are reality. They would name them, study their movements, and believe in their two-dimensional world with absolute conviction. Plato's question was simple, yet devastating. What if we are those prisoners? What if what we call the real world is merely a shadow play, and true reality lies just outside our perception in a world of perfect forms we cannot see? Centuries later, the philosopher René Descartes took this idea to a more personal, more unnerving place. He sat by his fireplace and imagined an all-powerful, malicious demon whose sole purpose was to deceive him. This demon could create a world so perfectly detailed, so internally consistent, that Descartes would never know he was being tricked. The warmth of the fire, the chair he sat upon his own hands, all of it could be an elaborate fabrication fed directly into his mind. His question was not about shadows, but about the very foundation of knowledge. If such a deception is even possible, how can we be certain of anything? For both Plato and Descartes, this was a thought experiment, a tool for exploring the limits of knowledge and the nature of reality. But in our modern age, an age of supercomputers and virtual worlds, this ancient philosophical query has found a new technological form. It is called the simulation hypothesis. The idea was given its most rigorous modern framing by the philosopher Nick Bostrom. His argument is not a wild claim, but a quiet, careful piece of logical reasoning. It does not state that we are in a simulation. Instead, it presents a trilemma, a set of three possibilities, and argues that one of them is very likely to be true. The logic begins with a simple assumption that it is possible for a technologically advanced civilization to create what are called ancestor simulations, highly detailed simulations of their past, populated with conscious beings who are unaware they are simulated. Think of it as the ultimate historical documentary, one you can live inside. If such a thing is possible, Bostrom suggests we are left with three stark outcomes. The first possibility is that civilizations at our stage of development almost always destroy themselves before reaching the technological maturity to create such simulations. This is the great filter hypothesis. Perhaps cosmic evolution is littered with promising species who discover the power of the atom, or alter their climate, or create uncontrollable technologies, and then simply cease to be. If this is true, then very few, if any, civilizations ever get to the simulation building stage. The second possibility is that civilizations do reach this advanced stage, but for some reason they lose interest in running ancestor simulations. Perhaps they develop a universal code of ethics that forbids the creation of artificial consciousnesses who would experience pain and suffering. Perhaps they become so advanced that exploring their own past seems trivial, and they turn their attention to other, more profound pursuits. In this scenario, the universe may be full of mature civilizations, but they simply choose not to create simulated worlds like ours. This brings us to the third possibility, and it is here that the argument takes its most dramatic turn. If the first two possibilities are false, meaning that civilizations do survive to reach technological maturity, and they do run many of these ancestor simulations, then a simple matter of statistics comes into play. For every one base reality, there would be billions, perhaps trillions of simulated realities. Imagine a single real Earth, and then imagine all the computers on that Earth, each running countless simulations of Earth's history. If you were a conscious being awakening into existence, where would you be more likely to find yourself? In the one original base reality, or in one of the trillions of simulated ones? The odds by sheer numbers would overwhelmingly suggest you are inside a simulation. So the trilemma stands: either humanity is doomed, or we will lose interest in this kind of technology, or we are almost certainly living in a computer simulation. Let us return to our wanderer. They are standing at the invisible wall on the mountain, pressing their hand against the void. The world on the other side looks real, the clouds, the distant peaks, but it is a painting, a skybox. The discovery doesn't fill them with terror. It fills them with a strange sense of clarity. The predictable townsfolk are not simple-minded. They are running on scripts. The repeating textures are not a flaw in creation. They are an efficient use of memory. The laws of this world, how gravity works, how magic flows, are not fundamental truths. They are the rules of the game engine. The Wanderer's world has a creator, a programmer, a god of a sort. And what of our world? If we were inside a simulation, how could we possibly know? The challenge is immense. Any experiment we could devise to test the nature of reality would itself be conducted within the rules of that reality. If we found that spacetime was not continuous, but made of discrete units, like pixels on a screen, would that be proof of a simulation? Or would it simply be a fundamental property of our universe's physics? A sufficiently advanced simulation would be indistinguishable from reality, because to its inhabitants it is reality. The laws of physics, from the strong nuclear force to the speed of light, could simply be the parameters of the code, the constraints set by the system's architect. The evidence, then, might not be found in a glitch or an invisible wall. It might be hidden in the very elegance and mathematical consistency of the universe itself. The fact that our reality can be described so perfectly by the language of mathematics has long been a source of wonder for scientists and philosophers. Is this because the universe is inherently mathematical? Or is it because the universe is running on a computational substrate, and mathematics is simply the language of its code? This idea can feel dizzying, even alienating. But perhaps it doesn't need to be. The label we give to our reality does not change the experience of living within it. The warmth of the sun on your skin is no less real to you if it is the product of nuclear fusion or a line of code in a cosmic computer. The love you feel for another person is no less profound. The sorrow of loss is no less sharp. The ghost in the machine is our own consciousness, the subjective first-person experience of being alive. Whether the machine is a universe of atoms and energy, or a universe of logic, gates, and information, the ghost within our capacity to feel, to wonder, to create meaning remains. The wanderer standing on the edge of their known world feels this instinctively. Their world may be authored, but their journey within it is their own. Their choices matter. The questions they are asking are real. The realization of their world's nature is not an end, but a beginning. It transforms their quest from one of exploring the world to one of understanding its creator. What were their intentions? Is there a purpose to this grand design? This is where the philosophical thought experiment brushes up against the discipline of science. While we may not be able to prove or disprove the simulation hypothesis definitively from within the system, it inspires a new kind of curiosity. It prompts us to look at the universe with a fresh eye, searching for clues in its most fundamental workings. We move from asking, "What if?" to "How can we look?" We begin a careful, methodical search for any subtle sign, any unexpected pattern, any faint artifact in the fabric of reality that might betray its true nature. We begin the search for a signature. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of some higher, unseen reality? It is a thought of breathtaking scale, a story that expands the walls of our cosmic home to infinity. And yet a beautiful story is not the same as a true one. For science, the most elegant tapestry of ideas is worth little if it leaves no thread, however faint, for us to follow in the material world. It demands more than a compelling narrative. It demands a signature. And so, we must step back from the dizzying heights of pure theory and plant our feet firmly on the ground. We leave the realm of the philosopher and enter the workshop of the physicist, where ideas are put to the test. Here the search for other universes and hidden dimensions is not a matter of meditation, but of measurement. It is a form of cosmic archaeology. The scientists engaged in this work are not unlike historians sifting through the dust of a long-lost city, searching for a single shard of pottery, a faded inscription, or a subtle change in the soil that tells a story of what once was. They are listening for a whisper in a storm of cosmic data, looking for a footprint on a shore that may have been washed clean by billions of years of time. This search is governed by one of the most vital principles in all of science, the principle of falsifiability. It is a simple yet profound idea. A scientific theory is not strong because it can be proven true, but because it makes predictions that can in principle be proven false. A theory that explains everything that can accommodate any possible outcome is not a theory at all. It is a closed room with no windows. But a theory that says, if I am right, you should see this specific effect. And if you do not see it, I am wrong. That is a theory with a door to reality. It is an honest wager with the universe. The theories of a multiverse and extra dimensions, for all their strangeness, have been carefully constructed to make such wagers. They propose that the existence of these unseen realms should leave subtle, detectable artifacts in our own. The search for these artifacts is happening now, at two vastly different scales, the infinitesimally small and the cosmically large. Our first archaeological dig site is at the very frontier of the subatomic world. Here in the heart of colossal machines, like the Large Hadron Collider particles, are accelerated to nearly the speed of light and smashed together, recreating for a fleeting instant the unimaginable energies of the early universe. The goal is to see what comes out of these collisions, to study the fundamental building blocks of reality. According to some theories of extra dimensions, especially those in string theory, The four fundamental forces of nature are not all confined to our universe, our brain. Electromagnetism and the nuclear forces they suggest are like residents bound to their home, stuck firmly within our three spatial dimensions. But gravity, the theory goes, is different. Gravity is a property of spacetime itself, and if there are more dimensions to spacetime, gravity should be free to travel through them all. This leads to a fascinating prediction. It could explain why gravity seems so much weaker than the other forces. It's not that gravity is inherently weak, but that its influence is diluted, spread out across dimensions we cannot see. It's like hearing a conversation in another room. The sound is muffled, its energy dissipated by the walls it must pass through. If this were true, then at very high energies and incredibly small distances, the very conditions created in a particle collider, we might see gravity's behavior change. We might see its true strength revealed. So the cosmic archaeologists sift through the debris of these collisions, looking for a specific signature, missing energy. When two particles collide, we can meticulously measure the energy and momentum of everything that flies out. These numbers must add up. Energy cannot be created or destroyed. But if a new particle, a graviton, were to be created in the collision and immediately escape into another dimension, it would carry energy away with it. From our perspective, it would simply vanish. The final sums wouldn't add up. There would be an imbalance, a whisper of energy that has gone missing, a clue that it has leaked out of our known world. Another even more dramatic prediction is the creation of microscopic black holes. Not the city-swallowing monsters of deep space, but unimaginably tiny fleeting entities that would evaporate in a fraction of a second in a puff of radiation. If our universe has more dimensions than we perceive, it would be much easier to concentrate enough energy in a small enough space to create such an object. Finding them would be a revolutionary confirmation. For years, these experiments have been running. Data has been collected, analyzed, and reanalyzed with painstaking precision. And what have we found? So far, nothing. No missing energy beyond expected margins of error. No fleeting black holes. At the smallest scales we can currently probe, gravity behaves exactly as Einstein predicted it would in our familiar 3 dimensions of space and 1 of time. For the cosmic archaeologist, this is like excavating a site where a great battle was rumored to have taken place only to find undisturbed soil. It is not a failure, but it is a null result. It tells us that if extra dimensions exist, they are either smaller than we can currently measure, or they interact with our world in a way that doesn't produce these specific signatures. The search has narrowed, but the mystery remains. And so we turn our gaze from the infinitely small to the unimaginably large. Our second dig site is not a tunnel deep beneath the earth, but the entire sky itself. We are looking at the oldest light in the universe. It is called the Cosmic Microwave Background, or the CMB. It is the afterglow of the Big Bang, a faint, pervasive radiation that fills all of space, a snapshot of the universe when it was just a few 100,000 years old. At that time, the cosmos was a hot, dense, glowing fog. As it expanded and cooled, the fog cleared, and the light from that moment was released, traveling across space for 13.8 billion years to reach our telescopes today. Looking at the CMB is like finding the universe's baby picture. It is astonishingly uniform, but not perfectly so. It contains tiny variations in temperature, minuscule hot and cold spots that represent the seeds of all future structures, the seeds of galaxies, stars, and ultimately us. It is here in this ancient light that some physicists hope to find a different kind of signature. The theory of brain cosmology imagines our universe as a vast three-dimensional membrane, a brain floating in a higher dimensional space called the bulk. But it might not be the only brain. There could be countless other parallel universes, other brains drifting through this bulk, like pages in an infinite book. And what if two of these universes were to collide? The energies involved would be cataclysmic, a collision on a scale that dwarfs anything we can imagine. Such an event, in the distant past, the theory predicts would have sent a shock wave through our universe, a ripple that would leave a permanent mark on the cosmic microwave background. The signature would be a distinct pattern, perhaps a large circular cold spot or hot spot, a cosmic bruise left behind by the impact. It would be an echo of contact with another world. This is not just speculation. Scientists have actively scanned the detailed maps of the CMB looking for such anomalies, and they have found some. There is a famous region known as the CMB cold spot, a patch of the sky that is unusually cool. For a time it was a tantalizing candidate, a possible glimpse of a world beyond our own. But science is a careful and skeptical discipline. As our understanding has grown and our data has improved, other more mundane explanations have emerged. The cold spot could be a statistical fluke, a random fluctuation that is bound to appear in a map so large. Or it could be caused by a vast supervoid, an enormous region of space between us and the ancient light that is unusually empty of galaxies, which could create such a cooling effect. The cosmic bruise theory has not been ruled out entirely, but it is no longer the leading explanation. The evidence is ambiguous, the signature unclear. The archaeologist has found a curious circular marking in the ground, but it is impossible to say for sure if it was made by a long-lost structure or simply by a trick of the light and the shifting earth. And so, we find ourselves in a place of profound patience. The search for a signature continues refining its methods, building more powerful tools, asking smarter questions. But as of now, the multiverse and the reality of extra dimensions remain a beautiful, mathematically coherent story without a single, undeniable piece of physical evidence. We have found no leak in gravity. We have found no definitive bruise on the skin of the cosmos. This lack of proof does not mean the theories are wrong. Absence of evidence is not evidence of absence. It simply means the universe is under no obligation to reveal its deepest secrets easily. Perhaps we are looking in the right place, but we don't yet have the tools to see what is there. Perhaps we are looking in the wrong place entirely, and the clues lie somewhere we have not yet even thought to look. Or perhaps the other universes are by their very nature causally disconnected from ours, destined to remain forever beyond our reach. Their existence a matter of inference and philosophy rather than empirical science. This is the honest, sober reality of the scientific frontier. Yet while the grand search in our colliders and telescopes continues, a different kind of evidence has been quietly asserting itself, an argument that comes not from a new discovery, but from an old observation. It is a clue hidden not in the behavior of a distant quasar or a fleeting particle, but in the very fact that we are here to ask these questions at all. For when we look at the laws of our own universe, we find that it appears to be exquisitely, improbably fine-tuned for the existence of life. Change the strength of gravity by a tiny fraction, and stars would never form. Alter the mass of an electron ever so slightly, and the chemistry of life would be impossible. Our existence seems to hang by a thread balanced on a knife's edge of cosmic coincidences. Why is our universe so just right? It is a question that leads us from the search for physical bruises to a profound philosophical puzzle, from the realm of the telescope to the paradox of the puddle and the hole it happens to fit so perfectly. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection of something vaster still? This question hangs in the air, a quiet and persistent hum beneath the noise of our everyday lives. It asks us not about other dimensions, but about the very nature of this one. Why is it the way it is? Why does it seem so perfectly suited for us? For a long time, this was a question that belonged to poets and theologians. But as our understanding of the cosmos deepened, it became a question for physicists, a genuine and unsettling puzzle. We began to see the hidden architecture of reality, the fundamental constants and forces that act as the universe's operating instructions. We discovered that these instructions are written on a knife's edge. The force of gravity, for instance. If it were just a fraction stronger, stars would burn through their fuel in a cosmic flash, collapsing into black holes before life ever had a chance to evolve. If it were a fraction weaker, stars and planets would never have condensed from the primordial gas. The cosmos would be a thin, cold, and formless soup. The same exquisite balance applies elsewhere. The force that binds atomic nuclei together, the energy that pervades empty space, the relative masses of elemental particles. It is a list of dozens of such values, each one tuned with breathtaking precision. If you were to imagine the control room of the universe, you would see a panel of dials, each one needing to be set to an infinitesimally precise number. Nudge any one of them even slightly, and the resulting universe would be sterile. No stars, no chemistry, no planets, no carbon, no water, no life. The universe we inhabit, the only one we know, appears to be a statistical impossibility, a cosmic jackpot against all imaginable odds. And so we found ourselves staring at our own existence with a kind of baffled gratitude. The universe, it seemed, was exquisitely fine-tuned for life, for us. For a while this felt like an answer. It felt like proof of our own specialness, a sign that the cosmos was built with us in mind. But in science, as in life, an answer that feels too comfortable often hides a deeper, more interesting question. And to explore that question, we turn not to a supercomputer or a telescope, but to a simple sentient puddle. Imagine, if you will, a puddle waking up one morning. It is a clear, bright morning after a night of rain, and the sun is just beginning to warm the earth. The puddle gains consciousness, and for the first time it takes in its surroundings. It feels the cool, dark soil that lines its shape. It notices the way the sunlight shimmers on its surface, and it sees the reflection of a vast blue sky, a passing cloud, the trembling leaf of a nearby tree. And as it contemplates its existence, a thought of profound significance bubbles up from its depths. This is a truly interesting world I find myself in, the puddle muses. An interesting hole I find myself in. And it fits me rather neatly, doesn't it? It stretches metaphorically to feel its boundaries. It notices how the depression in the ground cradles it perfectly. The gentle slope on the left, the steeper incline on the right, the little pebble divot in the corner. Every contour of the hole seems tailor-made for the shape of the puddle. In fact, it thinks, growing more impressed with each passing moment, it fits me so perfectly that it must have been made expressly for me. The puddle spends its day in a state of quiet satisfaction. It watches the world go by, confident in the knowledge that its place in the universe is secure, that the very ground beneath it was designed to hold it. It is a comforting thought, a reassuring one. It gives the puddle a sense of purpose, a feeling of belonging. The whole, and by extension, the world, was made for it. The logic seems unshakable. How else could the fit be so perfect? The puddle has no way of knowing that the sun is rising higher in the sky, that the air is growing warmer, and that soon it will begin to shrink its reality, evaporating into the very sky it so admires. It does not understand that it was not the hole that was made for the puddle, but the puddle that was shaped by the hole. The hole came first. Its existence defined the puddle's boundaries. For centuries, humanity has been that puddle. We awoke into consciousness in this vast and intricate universe, and we looked around. We saw the sun that provides the perfect amount of energy, the atmosphere that gives us air to breathe, the planetary orbit that keeps our climate stable. We saw the laws of physics that allow for the complexity of chemistry, and the chemistry that allows for the miracle of biology. And like the puddle, we concluded, this universe fits us rather neatly. It must have been made for us. This is a deeply human conclusion. We are pattern seekers, meaning makers. When we see intricate design, we infer a designer. When we see a perfect fit, we infer intent. The fine-tuning of the universe felt like the ultimate proof of this. It was the cosmic equivalent of the perfectly shaped whole, and we were the water held within it, marveling at our good fortune. But what if the logic is backward? What if, like the puddle, we have mistaken the cause for the effect? This is the core of a simple yet revolutionary idea known as the anthropic principle. In its most basic form, the weak anthropic principle states that the conditions we observe in the universe must be compatible with our own existence as observers. At first, this sounds like a trivial statement. Of course, the universe allows for our existence, otherwise we wouldn't be here to observe it. It feels like saying, it's not surprising that I am alive, because if I were not, I couldn't be surprised. But this apparent circular reasoning hides a profound shift in perspective. It tells us that our very presence acts as a powerful selection filter. We can only ever sample from a universe that is capable of producing us. Imagine a lottery with trillions upon trillions of tickets. A winner is announced. The winner holding the lucky ticket might feel that some cosmic force willed them to win. The odds were astronomical after all. It feels like a miracle. But from the outside, the logic is simpler. With trillions of tickets sold, it was virtually guaranteed that someone would win. The winner is only surprised because they are the one asking the question. The trillions of non-winners are silent. The anthropic principle suggests we are that lottery winner. We look at the fine-tuned constants of our universe and are stunned by our luck. But we are forgetting about all the other possible universes, the silent, sterile, non-winning tickets. This is where the idea of the multiverse returns no longer as a mind-bending abstraction of higher dimensions, but as a potential solution to this deepest of cosmic riddles. What if our universe is not a single miraculous creation, but just one bubble in a vast, effervescent cosmic foam? What if there are countless other universes, perhaps an infinite number each with its own set of dials, its own physical laws, its own random configuration of constants? In this grander vision, the fine-tuning of our universe is no longer a mystery. It is a simple matter of statistics. In an infinite multiverse, every possible combination of physical laws is realized somewhere. The vast majority of these universes are duds. They flicker into existence and collapse in an instant. They expand into a cold, thin gruel of particles with no structure. They are wastelands of radiation or crushing gravity, utterly hostile to any form of complexity. They are the silent, non-winning lottery tickets. They are the countless dry holes across the landscape on a sunny day. But in this infinite garden of forking paths, it is inevitable that by pure chance, some universes will have the right numbers. Some will have the perfect settings for stars to form, for planets to coalesce, for carbon to be forged, and for life to emerge. And of course, it is only from within one of these rare life-permitting universes that conscious beings could arise and ask the question, why is our universe so perfect? We are the puddle, but not the only puddle. The landscape is vast, filled with countless depressions, and a cosmic rain has fallen. Most depressions were too shallow or too porous to hold water. But we find ourselves in one of the holes that was just right, and so we exist. Our existence does not mean the hole was made for us. It means we could only ever have found ourselves in a hole that could hold us. This shifts our perspective from seeing our universe as special to seeing it as selected. Our presence selects the data we see. We are not the beneficiaries of an impossible miracle. We are the inhabitants of an inevitable outcome in an infinite game of chance. This doesn't take away the wonder. In many ways, it deepens it. It replaces the tidy satisfaction of purpose with the breathtaking vertigo of immensity. It tells us that the conditions for our existence are not a gift from the cosmos, but a property of its infinite scope. We are no longer the center of the story, the sole reason for its telling. We are instead a single fleeting thought in an infinite mind, a single conscious puddle reflecting the sky on a planet, orbiting a star in a galaxy within one of countless universes. The whole was not made for us, but the fact that we are here, aware and wondering, held within its shape, feeling the warmth of our sun, and seeing the reflection of the clouds, remains the most astonishing thing we know. The puddle's awe was not misplaced, only its explanation. The beauty it perceived was real. The feeling of being perfectly held was real. The wonder is not that the whole fits the puddle, but that any puddle should exist at all to notice the fit. And so we are left suspended between the intimate and the infinite. We have journeyed through shadows and dimensions across a landscape of countless possible worlds. We have seen how our own seemingly miraculous existence might be just one probable outcome in a sea of cosmic dice rolls. This perspective is vast, humbling, and perhaps a little cold. If this is just one reality among trillions, one island in an endless ocean of what-ifs, then what of this life? What of this consciousness, this specific and unrepeatable experience of being you right here, right now? Having looked so far outward to the very edge of possibility, it is time to turn our gaze back inward. For if our universe is but one of many, then our life within it becomes not less meaningful, but infinitely more precious. It is time to explore what it means to find our home not in a universe made for us, but in the one we happen to inhabit, to find a sense of place in the heart of infinity itself. Our journey began with a shadow, a flat and silent story told upon a wall. We saw how a being of two dimensions might live its entire existence, never knowing the fullness of the three-dimensional object that casts it. It was an exercise in humility, a gentle reminder that what we perceive is not always the whole of what is. But this idea, like a shadow, can be cast in another direction. If a three-dimensional world can create a two-dimensional one, could it be that our own world is but a projection, a beautifully complex shadow of a reality even grander, even more strange than we can conceive? And so, after wandering through the grand halls of possibility, after sailing the quantum seas and climbing the stairways of higher dimensions, we arrive at last at a quiet shore. It is the shore of home. The traveler, weary and filled with wonder, steps from the vessel of thought and feels the solid ground of the present moment beneath their feet. The air here is familiar. The light falls in a way you have always known. This is the world you were born into, the one single continuous story that is your life. And after witnessing the dizzying infinity of what could be, the question arises soft as a whisper on the wind. What does it mean to be here now in this one specific reality? For a time, the sheer scale of the multiverse can feel overwhelming, even diminishing. If every choice you could have made has been made in some other branching reality, does that not rob your own choices of their weight? If there is a version of you who succeeded where you failed, or a version who failed where you succeeded, what is the value of your particular struggle, your unique joy? The mind can reel feeling like a single grain of sand on an infinite beach. It is a natural response to such cosmic vertigo. We are accustomed to finding our meaning in the uniqueness of our path, in the finality of our decisions. But perhaps we have been looking at it from the wrong perspective. Consider the traveler returning home. They have seen mountains that pierce the clouds and oceans that glow with otherworldly light. They have walked through cities of unimaginable design. When they return to their own small village, is the familiar stream less beautiful? Is the old oak tree in the town square less majestic? No. In fact, it is the opposite. Because they have seen all the other streams and all the other trees, this one is no longer just a stream, but the stream. This oak is not just an oak, but the oak. Its textures, its specific arrangement of branches, the way the moss grows on its northern side, all these details, once taken for granted, now shine with a profound and specific reality. The journey through the vast and the varied does not diminish the home. It consecrates it. In the same way, your life, this one singular thread in an infinite tapestry, is not made meaningless by the existence of the others. It is made precious. Out of all the realities that could be, this is the one you are experiencing. Your choices are not about creating a reality from nothing, but about navigating and illuminating one path through the infinite garden. You are the lantern bearer on one specific trail. The other trails exist winding through twilight and shadow. But this one, the one beneath your feet, is bathed in the light of your awareness. The joy you feel is not a generic joy that exists everywhere. It is your joy felt in this body at this time. The love you give and receive is not an abstract concept, but a tangible, specific warmth that colors this universe. The act of choosing, of committing, of living through a single sequence of events is what gives your story its shape, its texture, its unrepeatable soul. It is the act of a sculptor finding one perfect form within a block of infinite potential. There is another way to find our footing in this vast cosmos. It is the idea that consciousness is not an accidental byproduct of complexity, but a fundamental aspect of reality itself. Some physicists and philosophers have wondered if the universe, in all its mathematical elegance, only truly becomes real when it is observed, not necessarily by a human, but by any conscious agent capable of witnessing it. In this view, we are not small, insignificant specks, lost in a cold, indifferent void. We are the universe's way of knowing itself. Imagine a library that contains every book that could ever be written, an infinite collection of stories, tragedies, comedies, and epic poems. The library is silent, dark, and still. The books exist as pure potential, their words and worlds locked away in the darkness. Now imagine a reader enters. They take one book from the shelf, open its pages, and begin to read. In that moment, a world is born. Characters breathe landscapes, form a story unfolds. The book has not changed, but in the act of being read, its potential is made real. Its universe comes alive through the consciousness of the reader. Perhaps we are that reader. The multiverse is the infinite library. And this life, this one conscious experience, is the act of reading one of its books. We are the aperture through which the cosmos experiences a sunrise. We are the nerve endings through which it feels the warmth of a fire or the coolness of a gentle rain. Through our eyes, the colors of a nebula, a billion light years away, are not just frequencies of light, but are perceived as beauty, as awe. Through our minds, the laws of physics are not just equations, but a source of wonder and understanding. In this light, our existence is not a cosmic accident. It is a cosmic necessity. We are the meaning makers, the storytellers, the witnesses who turn the silent potential of infinity into the lived experience of a universe. And so the journey home is complete. Let your awareness, which has traveled so far now, come to rest. Feel the gentle weight of your body, the solid support of the surface beneath you. Notice the quiet rhythm of your breath, an anchor in the here and now. This breath, this simple, effortless rise and fall, has been with you through every moment of this one precious life. It is the metronome of your personal universe. Listen to the sounds of your immediate world, not the imagined echoes of other realities, but the real, tangible sounds of this room, this moment. The soft hum of the air, a distant car, the beating of your own heart. These are the sounds of home. They are the soundtrack to your story. There is no need to grasp for infinity anymore. You contain it. Every atom in your body was forged in the heart of a star that died long ago. The history of the cosmos is written in your DNA. You are not separate from this grand, mysterious universe. You are a thinking, feeling, wondering part of it. The awe you feel when you look up at the night sky is the universe recognizing itself. The garden of forking paths is vast, but you are not lost within it. You are here on this path. This is the one that matters. This is the one where you can love, where you can learn, where you can be kind. This is the one where the morning sun can warm your face. Let the knowledge of all the other paths fade into a soft, shimmering background, a beautiful context that makes this present moment shine all the brighter. You are home. You have always been home. And this home, this one life, is more than enough. The great exploration of the outer cosmos and the inner self leads us not to an escape, but to a profound homecoming. We journey to the edges of possibility only to discover the sacred ground on which we already stand. The mystery of the universe is not something to be solved, but something to be lived. And in the quiet miracle of a single conscious moment, we find that the meaning we were searching for across all of time and space was here with us all along.